Good afternoon, Code Milkers. Today we are doing number of islands. It's day 17 of the 30-day LeetCoding challenge. And thank God we're halfway done. Today's question, I had seen probably like a week ago. I was going to do this problem, number of islands. It's like a medium one, and it was one of the harder mediums. It has like a 30% acceptance rate for submissions. So I knew what this question was when I clicked on Explore for the day, and I knew I wouldn't be able to solve it in under like 45 minutes or so, which puts it beyond what I can render in under 6 hours with this computer. So I went ahead and just completed the problem. It took me around 45 minutes, like what I thought it would, and I'll just walk you through my solution today. So today, the problem was number of islands, and here are the directions. Given a 2D grid map of string ones, not numbers, string ones and string zeros, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. You may assume all 4 edges of the grid are surrounded by water. Then we have a few different examples here. And the significance of the 1 and 0 is that a 1 represents land and 0 represents water. So if you hit a 0, as you're going across, like, say, an example string of 1110, like in this example, you know you've hit water once you hit the 0. So the island at least is done forming at that point. The 0 is where the island stops. And a nice little addition to this problem, a nice constraint that they add, is you may assume all 4 edges of the grid are surrounded by water. So if you know you are like at a point where you're at an index less than or greater than the string's length, or the entire array of the 2D grid's length, you know the island cannot extend past that because it is completely surrounded by water. So let's go through this first example. We have an array with 4 strings. We have the first string is this one, second string is this one, and so forth. So here we have 1 island because we have 4 ones here connecting horizontally, and we also have a 1 that is vertically connected to that top string. And then in the next row down, we have 2 ones connected horizontally, and then beneath that, in the next row, we have 2 ones connecting vertically across the whole island. So we only have 1 island through this whole example. You might look at the 1 here and think, oh, that's its own island, but it is connected vertically to this one. It's kind of hard to see. This example here, that's fine. This example here, we have an 11 followed by 3 zeros, 11, 3 zeros, 1, and 11. So here it's 3 islands because we have an island here, not including the zeros. The zeros don't count as an island, it's just the way it's highlighting. These 4 ones, this one, and these 2 ones constitute separate islands because they have to connect horizontally or vertically. They cannot be diagonal. So even though this 1 is connected to this island diagonally, doesn't count. And the same with this 11 to this 1, they don't count. They're their own islands. So we have 3 islands total there. So now to get into my solution, I want to draw something on, let's see, on the whiteboard. Here we go. So if we think about a 1 in the grid, and we're going to surround it by water, we can think of a specific spot in the map think of it in relation to the cardinal directions. So north, south, east, west. Basically, the sub-problem we want to figure out for each spot in the grid is it connected to any other one? Either above it, below it, to the left of it, or to the right of it. If we can solve that problem, we've essentially figured out the entire problem. So basically, we're going through the array, and we're going through each string, and figuring out for each spot, if it's a 1, we need to figure out how many 1s it's connected to, either top, bottom, left, or right. And if it's a 0, we just pass it. Because it's water, we don't need to worry about it. The little catch, though, is that as we go through these strings in our array, we need a way to mark the ones that we visited as visited. And we can do that just by marking it 0. Because 0 means we don't need to worry about it, we'll just pass it. We don't need to put like a V to show we visited it or anything. Just mark it 0, and we can continue on with the array. So let me clear this drawing. If we have a 1, 0, a 1, 0, and a 1, and then we'll go a little further. Okay, so this is our grid here. Imagine there's commas between all of these. The way we can iterate through the array is each string at a time. So we'll go with this one first, this one second, and this one third. So as we're going across here, the 0, don't worry about it, we just pass it. 0, it's water, we don't do anything. Now the 1, now we found some land. So we're gonna imagine that we have the cardinal directions here. We're gonna sub in a 0 here, sub in a 0 here, because the outside of the grid is all water. There's no land beyond the grid. So we can assume there's zeros. So we go to the left. Do we have land? No. So we stop looking horizontally to the left. Vertically, do we have land? Nope. We stop looking that way. Do we have land going to the right? Nope. Stop looking horizontally completely. Do we have land going to the south? We do have land going to the south. We actually have a few different spots going south. So we need to treat this as its own subproblem. So now we're looking at 1, 1, 1, and 1. Now, since we said we need to mark the previous spot as visited, we need to change that 1 here to a 0. We've already incremented the island count by 1 at this point. Now we just want to figure out how far this island stretches so we don't end up incrementing the island count inaccurately for a piece of land that's actually connected to the island that we just found. So now this 1 is actually a 0, because this 0 represents this 0. So now we're looking at this subproblem. So from this spot, do we have land to the left? Yes, we do. We'll return to that in a second. Do we have land to the right? No. North? Nope, we don't. It's already 0, but we already incremented the island, so it's all good. To the south? We do. So we have 2 new subproblems we have to work with here. We have to the left and to the south. So let's clear this out after right here. Now we visited this spot, we mark a 0. And now we have our new subproblem with going to the left and with going to the bottom. Okay, scratch the 0, imagine it doesn't exist. So we go from this subproblem, so it's the one to the left of our original drawing. there is no land anywhere connected to it, so we mark this as 0, and we stop recursing at that point. Spoiler, we're recursing. Next, we go to that south subproblem, and we are surrounded completely by water, so we stop recursing, mark that as a 0, and we're good to go. Okay. So let's share our LeetCode. All right. So essentially, this problem is the recursion of a specific spot if it's a 1. And we need to figure out how far that piece of land stretches out to. So that's why we use recursion, because we're moving outward from that spot. Specifically from that spot, we need to just go in all directions. So recursion makes the most sense for this. You can either use a breadth first search or a depth first search. I think a depth first search works better for this problem because you want to go in one direction the complete way for any given spot. And that's what you're doing with a depth first search. You're going all the way in one direction. So you're just piercing all the way to the end. So I use a depth first search here, as you can see with this constant variable declaration here. So I'll just run you through the code. Island count obviously is the number of islands. We started at 0. Then we're going row first, and a row is the specific string in the grid, and our sub loop here, our nested loop, is counting which column we're at in the string, so which index. So we're seeing if the current spot at the given row, so in the given string at the current index is 1, then we have to increment island count by 1, and then we also need to do a depth first search to see how far that island really stretches. So now we come down here to the depth first search. I will come back to this is water function in just a minute. So we immediately, when we're recursing, we mark the current spot as a string 0. Just like we showed on the whiteboard, we need to do that so that we don't end up entering an infinite loop where we keep checking the 1 that we already visited. So here we're searching to the right. Here we're searching to the left. Here we're searching... No, actually, here we're searching the right. Here we're searching the left. Yeah, this is a typo. Because the row plus 1 means it's going down, and the row minus 1 means it's going up, because we're moving across the strings, not moving along the index of a specific string. Yeah, so scratch these notes here. We recurse with depth first search for each given spot, and if it is not water, we need to do the depth first search again and mark the current spot as 0. So we know that something is water. We'll go to this. We check it first when we recurse. We know it's water if the grid row is undefined, which means that we're beyond the bounds of the number of strings in the array. We know that we are out of bounds if our grid, if the given row for a given column is undefined, we're beyond the bounds of the grid, which automatically means it's water. And also, if the current column position is a 0, we know it's water. Yep, and that's how we do the recursion for this problem. I'll run the code, show you it works. We can look at the time complexity. I honestly do not know if this is linear time. I don't think it is because of all the recursion that's happening. If anyone knows what the time complexity of this is, I would love to hear what it is. Earlier it beat 75% of JavaScript, so within the range of 37 to 75 is probably average for this. Have a great day.